R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss the topic on Biot Savart's law and its applications for the unit steady magnetic field. So, an introduction to Biot Savart's law. So, Biot and Savart conducted experiments on the force exerted by an electric current on a nearby magnet. They arrived a mathematical expression that gives the magnetic field at some point in space due to a current. The magnetic field described by the Biot-Savart's law is the field due to a given current carrying conductor. So, to explain the Biot-Savart's law, in the diagram there is a current element having length dl is taken, and at distant point P, from the current element to point P is taken as R, and we have to observe the magnetic field at point P from the current element. And here theta is the angle between this current element and the line joining from the element to the point P. And let I is the current flowing through this current carrying conductor. And for this, the Biot-Savart's law states that the magnetic field intensity dH produced at point P due to differential current element ideal is proportional to the product of the current I and the differential length dl. Secondly, the sine angle of the angle between the element and the line joining point P to the element. And finally, it is inversely proportional to the square of the distance r between point P and the element. So, we can express these with a mathematical expression according to Biot-Savart's law. dH is given by ideal sine theta by r square, and by removing this proportionality constant, we can add the k parameter which is constant of proportionality. So, the expression dH can be given as ki dl sine theta by r square, and in SI units this constant of proportionality k can be given by 1 by 4 pi, and so dH is ideal sine theta by 4 pi r square. So this is the equation of Biot-Savart's law after substituting the k value. And now let us express this expression in vector form. So in vector form, dl is the magnitude of vector length dl vector, and ar vector is the unit vector in the direction from differential current element to the point P. So from a rule of cross product, we can write dl cross ar vector is equal to dl ar magnitude sine theta, and we can we know that the magnitude of ar is equal to 1, so we can write that dl cross ar vector is equal to dl sine theta because ar is equal to 1. So by substituting in the dH equation, we get dH is il cross ar vector by 4 pi r square, and this is the magnetic field expression, so the unit is ampere per meter square, and this ar vector is r vector by magnitude of r, so we can write r vector by r. So by substituting this value in equation 4, dH becomes ideal cross r divided by 4 pi r cube ampere per meter, and this equation 4 and equation 5 are known as mathematical form of Biot-Savart's law. So the entire conductor is made up of such differential elements. So to obtain total magnetic field intensity H, the above equation, that is equation 4, takes the integral form. So H is equal to integral over the entire conductor length ideal cross ar by ar vector by 4 pi r square, and so this will be expressed in integral form. So we have a conductor, and the distance between the conductor and point P where we are observing the magnetic field is taken as R12, and let the current carrying element current is through the element is I1, and this current on the element is I1 dl1. And now the magnetic field across this current element dh2 is equal to I1 dl1 cross ar12 vector by 4 pi r12 the whole square ampere per meter. So we can define each terms as I1 is current flowing through dl1 at point 1, and dl2 is differential vector element at point 1, and here ar12 is unit vector in the direction from element at point 1 to the point P at point 2. And here AR12 is R12 by R12 modulus of R12. It is R12 vector by R12. So by substituting we get H2, the magnetic field is integral of I over the entire length I1 dl1 cross AR12 by 4 pi R12 the whole square amperes per meter. So this is called the integral form of Biot Savart's law. So according to Biot Savart's law, there are various factors influenced. So one is the distance. The magnitude of magnetic field varies as the inverse square of the distance from the source. So the electric field due to point charge also varies as the inverse square of the distance from the charge. And if we take the direction, the electric field created by the point charge is radial in direction. So we can conclude that the magnetic field created by a current element is perpendicular to both the length element and the unit vector. And third is source. An electric field is established by an isolated electric charge. So the current element that produces the magnetic field must be a part of an extended current distribution. Therefore, we must integrate over the entire current distribution. So we can use the Biot Savart's law for any finite length of current carrying element, and we can calculate the magnetic field at some point P from the current element. So this is illustrated in the figure. And now the assessment question, the Biot Savart's law statement, and we know the integral form of Biot Savart's law. Thank you.